In this video, we're going to talk about web components. You might have heard about them. You might have even read about them online, but the reality is web components is still a new technology and most companies have not adopted them yet. So what are web components? What's the fuss about them? Well, web components are a set of web platform APIs that allow you to create new, custom, reusable, encapsulated HTML tags to use in web pages and web applications. Web components are based on three main specifications: custom elements, shadow DOM, and HTML templates. Custom elements are a set of JavaScript APIs that allow you to define custom elements and their behavior, which can then be used as desired in your user interface. A custom element has its own semantic HTML tag and lifecycle methods, similar to React components. Shadow DOM. A set of JavaScript APIs for attaching an encapsulated shadow DOM tree to an element and controlling associated functionality. Encapsulation is something that traditional HTML and CSS totally lacked. With Shadow DOM, you can keep an element's features private, so that they can be scripted and styled without the fear of collision with other parts of the document. The new template and slot HTML elements enable you to write markup templates that are not displayed in the rendered page. This can then be reused multiple times as the basis of a custom element structure. Of course, you can also use HTML templates for normal HTML elements as well. The beauty is, custom components and widgets built on the web component standards will work across modern browsers and can be used with any JavaScript library or framework that works with HTML. So, how well are these features supported? In general, the support is good in modern browsers, but unfortunately it's not complete. Web components are supported by default in Firefox from version 63 onwards, Chrome and Opera. Only the very latest versions of Edge support all three specifications. Safari supports an incomplete set of web component features, and it's currently in technical preview state. The good news is there are polyfills available if you want to use web component features in the browsers that currently do not support them. There are a few libraries that make it easier for developers to build web components. They're all built on top of the official web component specifications and provide APIs and syntactic sugar that make it easier to build them. These libraries are Polymer, Slim.js, Stencil, Hybrids. And even Angular provides a special function called Create Custom Element that can convert an Angular component together with its dependencies into a custom element. Okay, let's take a deep dive into each of the previously mentioned specifications one by one. First, custom elements. Custom elements are in essence fully valid HTML elements, just like div or article, but they have custom templates, behaviors, and tag names made with JavaScript APIs. They would always have a hyphen in their name. A custom element is defined using JavaScript's class keyword that extends HTML element. Once defined, the custom element can be reused as many times as you need in your application. A custom element is a way of defining an HTML element by using the browser's JavaScript API. A custom element has its own semantic tag and lifecycle methods, similar to a React component. As you can see, the button component custom element in our example extends an HTML element. It even has a lifecycle method connected callback, which is called whenever the element is added to the DOM. Then it and its tag get registered with customelements.define function. We need to mention that there are two types of custom elements: autonomous custom elements and customized built-in elements. Autonomous custom elements. They are standalone. They don't inherit from standard HTML elements. We use these on a page by literally writing them out as an HTML element. For example, pop-up info or document.create pop-up info. Now, let's create an autonomous custom element. To begin with, the JavaScript file will define a class called InfoBox, and we'll make the class extend HTML element. Inside the constructor, we will define all the functionality the element will need to have. So first, let's create a shadow root. Then let's insert an icon, and we'll use the actual source of the icon to be equal to the attribute of the element. This .get attribute allows you to do that, and you'll see how it's used a little bit later. Next, we'll similarly use the content attribute and assign it to text content of the info box. We created a new element span, and we populated the text content from the data text attribute that you'll see how it's used in a few moments. And lastly, let's just add some CSS so that the info box doesn't look completely bad. And then we can attach the CSS style into the shadow root. Now, to complete this, we need to define the custom element and give it some sort of HTML tag. In this case, it will be info-box. And now we can use it in our HTML like this. As you can see, I'm providing the image in the HTML attributes and the text in data text attribute, and it's rendering on the screen. Customize built-in element. It's an element that inherits from another basic HTML element, such as button, to create a customized version of the existing element. They can be used by writing basic HTML element and specifying the name of a custom element using is attribute. For example, here, alert button is a custom element which extends HTML button element. Now, let's build a customized built-in element ourselves. We will create an alert button class by extending HTML button element. This is the start of our customized built-in element. Let's add some simple functionality to it. The alert button will show an alert when you click on it. We will put the event handler into the constructor for simplicity, and it will read the content of the alert box from HTML attribute data text. When registering the custom element, we'll provide a third argument that specifies which HTML tag we want to extend. There may be different tags that share the same DOM class. That's why specifying extends is needed. At the end, let's use our custom element. We'll insert a few button tags and specify that they're being extended by alert button. This HTML attribute does exactly that. Now, when we click on the button, as you can see, an alert box is shown. Before we move on to the next specification, there's something else I want to mention. One important thing you want to know about custom elements is they all have lifecycle methods. These are different callbacks inside an element class definition. These callbacks are called at different times of the component's lifecycle. Connected callback. It gets called when the element gets attached to the document's DOM. Disconnected callback. It gets invoked each time when the element is removed from the document's DOM. Adopted callback. It invokes each time when the custom element moves to a new document. Attribute changed callback. It invokes each time when any of the attribute gets added, removed, or changed. The attribute for which we have to notice the change is specified in the static getObservedAttributes method. Let's use the original info box to understand how a lifecycle callback works. We are going to add a connected callback method that will add some text after 2 seconds. These are going to be the methods. Now, when we refresh the page, you'll see that "Have you used it yet?" text appears after 2 seconds. We could obviously make it a bit smoother by adding some CSS that will make the text appear with a fading animation. Something like that. It's not like it's pretty, but I just wanted to show you how the connected callback lifecycle works. You can experiment with other lifecycle callbacks yourself. On to the next specification. Shadow DOMs. A shadow DOM is an encapsulated version of the DOM. A shadow DOM allows hidden DOM trees to be attached to elements in the regular DOM tree. This shadow DOM tree starts with a shadow root, which you can use as a normal DOM document. You can attach elements of your liking and apply CSS without affecting external style sheets outside the shadow DOM. There are some bits of shadow DOM terminology that you need to be aware of. Shadow host, the regular DOM node that the shadow DOM is attached to. Shadow tree, the DOM tree inside the shadow DOM. Shadow boundary, the place where the shadow DOM ends and the regular DOM begins. Shadow root, the root node of the shadow tree. Note that the shadow DOM is not a new thing by any means. Browsers have used it for a long time to encapsulate an inner structure of an element. Think, for example, of a video element with the default browser controls exposed. All you see in the DOM is the video HTML tag, but it contains a series of buttons and other controls inside its shadow DOM. I already showed you what shadow DOM does when I was building the info box, but I'll provide a more isolated example now. Let's say we have this markup. There's nothing special to it. And let's say I want to attach a shadow DOM to the div with ID example. And the way to do that is by getting the element by ID and calling the method attach shadow. Now that by itself doesn't visually change anything, so we can fix that. Let's attach a new style sheet that will make the DOM tree have the background yellow. And here's the effect. And another thing I'd like to do is I'd like to add some text into it. So now you saw that when the page got refreshed, the inner paragraph indeed disappeared and got replaced with the dynamically added text. This is the intended behavior of shadow DOM. It replaces the content that was there before the shadow DOM was attached. In order to preserve the content, we need to add an HTML tag called slot. So I can dynamically add it here. And the result will be that this text will stay, but of course it will be under the new shadow DOM tree. When you have to reuse the same markup structure repeatedly on a web page, it makes sense to use some kind of a template rather than repeating the same structure and recreating it over and over again. This was possible before, but it's made a lot easier with HTML template tag elements. An HTML template element and its content are not rendered in the DOM, but they can still be referenced using JavaScript. Quick example. This paragraph will not appear on your page until you grab its reference with JavaScript and then append its content to the DOM using something like this. Let's create a template for an employee's row that shows the employee's name, salary, and start date. This is going to be our HTML template, and the syntax is really simple. It starts with the word template, and you just put the content of the template inside the tag. And let's not forget to also add the heading and a UL element that we will populate with data in a few moments. Next, let's create our view models. It's just an array of employees. You can iterate through the view models above and attach the data to the template before attaching the result to the UL element. Before we would go forward, we will attach the first line item that will label the columns, so to speak, even though it's not really a table. But you'll get the idea once we do that. So to do that, let's just grab the fragment, which is literally the template, and grab the content of the fragment and populate it with some hard-coded labels. The result is as you see on the screen. And then we'll loop through the employees, copying the template and filling the template up with content. So we'll just grab the view models, which is an array of JavaScript objects, copy the fragment and set the content of this instance to the data from the view model item. The result is what you see on the screen. So let's reiterate the main benefits of web components. Reusability. Once created, web components can be imported, used, and reused in applications. Readability. Compartmentalized, reusable code reduces the application size, simplifies debugging, and makes it more readable. Declaration. You can more easily declare components on your page. Composability. Shadow DOM allows composing web applications with small chunks of code. Extensibility. Custom element APIs can extend browser elements or custom web components. Scoping. Shadow DOM ensures DOM and CSS scoping so that styles don't leak out of the shadow DOM, potentially creating conflicts in the global CSS style sheet. Interoperability. Native web components are interoperable at the browser's lowest DOM level.
Thanks for watching.
If you like the content we are providing,
Please like and subscribe to help us grow the channel. Thank you.